right, welcome back, guys. So now for the blue embers and sparks effects. Um, what you see here, all these good-looking sparks and all these good-looking embers in the shockwave. They getting sucked in. Um, let's take a look at them in Houdini now. So the one important thing that I want to mention before we start on with the sparks and embers is that how I organize the creation for all these effects for the blue stuff is I worked on the shockwave first, and because this shockwave has all the timing for the suction, for the expansion, and the twisting and the spinning forces, and all that. So what's important to note is that the shockwave drives most of the sparks and embers effects. So all I want to say is that I'm just going to quickly explain how I've done the forces for the axiom so that I could bring all that timing into other solvers as well. So we can see here there's a suck in and there's a push in and there's a spin force for the shockwave. So I've got the magnitude for the pressure on the suck in and this force timing, which is tied to this null node here inside this output animation. So all I've done was literally what we did for the wrangle by grabbing start frame and a duration and fitting the current frame with those start frame plus duration and 0 to 1. So that's literally how I did it. So if I just do it on a null node so you guys can follow along, let's put down a null node, call this force timing, forces timing, and force timing. All right, if I can spell right. And we just go to the gear icon down here, up here, and edit parameter interface. And all we want is 2 integer parameters. I'm just gonna hide these because we don't really need them. So this would be the start frame. Duplicate this, and this would be the duration. And another one would be our output range, our output animation timing. So it's going to be a float value, and this would be the output. All right. So apply and accept. So what we can do is do maybe 1080 and with a duration of 10 frames. So all we want to do on the output is fit the current frame with the start frame and max the start frame plus the duration and 0 to 1. And there you go. You can see how it changes. Zonk. So all I've done for that timing is copy this output animation and plug it into the pressure and into these source shapes, and for the push-in as well. Well, apparently for the push-in I've used a keyframe. What else? For this guy, the spin is using some more keyframes as well. But generally, the suck-in is the most important part for us, is because this will drive most of the forces that we'll be using for the sparks and embers. All right. I'm just gonna delete that off and head up, and I'll show you what I've done with the sparks, and this is how that spark stuff look. And they get sucked in as well with some spin forces. All right. So as you can see, we've taken that forces timing from the shockwave. So all I've done is create a reference copy of this guy. Actions, create reference copy, and this won't work because we're gonna have to, yeah, just get that out, paste that here, copy the start frame, paste absolute, copy this, paste absolute, and then for this, all I'm gonna do is do the exact same expression, and that should work perfectly fine. So that's all I've done. So this is here now, and in particle solver, I think I've referenced that timing in here, a global scale, which I just created. You put on pop axis force. It's a parameter that I created for myself, and this under pop attract as well, it's on there. Cool. So let's talk about the emitter for the sparks. So as you can see, we've got the this blue start point, which is essentially inside here. It's just a point where I initialized the start frame for the shockwave, for the impact, and just reading that in to here with an object merge, and all I'm doing is creating a pyroscatter from burst and setting the direction for the points, velocities pointing outwards, just like a shockwave would look like, and another one that points up. So if you see particle sim again, we've got particles that shoot outwards, and then some particles that are shooting upwards. So that's literally most of the gist of the sources. All I'm doing here is creating the well, I didn't create this. If you put down a pyroscatter from burst, under the quick setups, we can say simulated particles, and that will create all these neat little nodes for you automatically. And so that's all I've done. Setting the life, the mass, the drag. Just keep the start frame as well, so it only emits once based on the start frame that we have on this pyroscatter from burst. Cool. So inside the pop net, I've got 3 sources. So all this is just, if you look here, I've only got one source. Basically these are not reading anything. If you have a look here, let that play through. Let's move back a bit. I'm just gonna disable all these, and it's still working because these are not doing anything. I should just bypass these, actually. Bypass that, and that should still work just as fine. So what's happening here, I'm just creating obviously the pop force, the particles, setting some noises with some drag with a pop wind, then even more pop drag, and then this pop axis force, all it does is I'm creating down sphere shaped fall off spin force thing, and setting the radius and the height based on what I think is appropriate for our current situation. And then under the speed tab, all I'm doing is scaling all these parameters: the orbit speed, the lift speed, and the suction speed, based on the global scale parameter that I created. So this is the global scale parameter, and it's referencing, you guessed it, this node up here. So all it's done is copy that and then paste relative reference. So this scale variable is now reading that parameter, and we're multiplying all these parameters with that scale attribute. So there's that. And with the pop attract, I'm also using the same parameter upstream and multiplying the force scale with it. So that way you could just have everything stay consistent with all the timing. And there's really nothing special with all these. The pop attract just brings everything back into the origin, as my goal position is at the origin. So that's it. Really, nothing special there. And caching that out. And with this point velocity, I'm just calculating the speed, because what I want to do is hopefully be able to create some. So I'm saying here, these value attributes I'm creating down here are meant for the particle trail node. So there's a new node called the particle trail, very, very useful for particle sims. And if you just drop down, under the look, under the intensity, click on the dice icon down here, and this will literally create an attribute, a just float, that sets value up here. Now this value will be multiplied, will be used for the intensity, and that's pretty cool. So we've got that, we've got the value, and we've got, and all I'm doing to the value as well here is multiplying it with the speed. So what I'm saying is that if the speed is basically, if the particles are moving fast, then we'll have a stronger emission. So I'm just multiplying up here. And if the particles are moving slow, then let's reduce the emission. That's all it's doing. And for this, I'm just randomly multiplying down each of those particles, the value of those particles for the emission. Now, if you see this, you can see that they're tied to the speed of the particles. So as they stay afloat up here, hovering around, they turn a bit more blue, but as they get sucked in as well, they get even hotter. So that's pretty much it. And all of these are just to create the width attribute that I'm gonna have to use for rendering. And yeah, that's pretty much it for the sparks. Let's talk about the embers next. Well, it's a pretty similar situation with the sparks. So the embers are literally this, but with a different emitter, with a different source, and some different settings as well. So let's dive down and look around.